CIET NCERT presents audiobook Kaushal Bodh, textbook of vocational education for grade 8.
Page number 107. Part 3, Work in Human Services. There is a picture given at the bottom of this page. In this picture, there are some school students who are interviewing each other, and one of the students is recording the interview. Page number 108. Human services are about serving people and interacting with them in different ways. Projects on work in human services will help you learn how to work with people. You can take up projects related to taking care of your health and that of your family and others. You can make interesting videos and audio clips on various topics, or take up making a budget for your family, applying mehendi on people's hands, or developing a comic book. It is up to you to imagine all that you can do with your peers. 2 examples of projects are given in this section, which are water audit for water management and creating advertisements. You must take up only one project. You can either choose one of these projects, or you can design a project of your own choice with the help of your teacher. Page number 109. Project 5. Water audit for water management. There is a QR code given on the right-hand side top of this page. Scan this QR code to find additional resources for this project. A water audit is a systematic process through which data about water usage and wastage within a building or household is examined. This project is about collecting and analyzing data using different tools for water audit. As part of the project, you will be able to: first, collect data for tracking water use and wastage. Second, analyze data to estimate water use. Third, apply simple strategies to reduce water use and wastage. Fourth, use data to predict future needs for water. Figure 5.1. Carrying out a water audit in the community. There is a picture given in this figure of a rural area. There are some school students in this picture. 2 students are noting down the details. Another student is noting the time, and the last student is filling water in a bucket from a tap. Page number 110. Have you ever wondered how the meteorological department predicts the arrival of the monsoon or warns us about upcoming cyclones, rainfall, heat waves, and snowstorms? They make these predictions based on past data, assuming that similar trends will continue. Data is any information collected for a specific purpose in the form of facts, figures, photographs, videos, and so on. Figures 5.1 and 5.2. After collection, the data is organized so that we can interpret it and draw conclusions. For example, suppose we have data about temperature, humidity, and rainfall over a period of time. In that case, we can predict the chances of rain given specific conditions or temperature and humidity. Figure 5.2. Data is information in many forms collected for a specific purpose. There is a picture given in this figure where a girl is sitting in front of the computer and analyzing the different forms of data that has been collected. Imagine a village where farmers usually grow crops that need water. However, if past data on temperature and humidity show that a particular summer will be hotter and the rains will arrive late, the weather forecast can help them plan better. Instead of planting the usual crops, they can either delay sowing or choose crops that need less water. This way, they can avoid losses and better use their resources. In today's age of information technology, data is considered an essential asset since it provides crucial information to make informed decisions. Data helps us in everyday life. For example, by estimating travel time or finding an allergy to some food in our diet. It enables government departments to plan water release schedules from dams or prepare for traffic control during significant events. Page number 111. In this project, you will collect data on water usage in your locality. You will conduct a water audit by systematically examining its uses and identifying sources of wastage. The data collected on water usage will be used to estimate water usage in different scenarios. To get accurate results, the data collected has to be correct and authentic. Example, if you are collecting data on red cars passing a traffic signal in 1 hour, then a car of any other color will not be included. Reliable. Example, even if 2 people are collecting data on red cars, they must come up with the same data and obtained by experiment or from a source that can be trusted. Example, before data collection, observers decide the color will be considered red. This process will also prepare you to analyze different kinds of data. Water in India, a big challenge. India has only 4% of the world's fresh water, but nearly 18% of the world's population. At the same time, water is not available equally everywhere in the country. Some places face floods, while others experience droughts. Droughts are often seen as natural disasters, but in reality, they are primarily caused by human activities, such as deforestation, poor agricultural practices, and over-extraction of groundwater. They are also due to mismanagement and misuse of water at the micro, household, and macro, district or state levels. Did you know that leaving a tap running for 5 minutes can waste 45 liters of water? Are we using our water carefully? Or are some of us using water irresponsibly and wasting others' share of water? Some people struggle to get water, depending on water tankers or walking long distances to fill a single bucket. At the same time, thousands of liters are wasted due to leaks and careless use. Page number 112. The good news is that there are various people's initiatives for water conservation, such as rainwater harvesting, recycling water, restoration of water bodies, and so on. Several government efforts have also been initiated, including the Jal Jeevan Mission and Jal Shakti Abhiyan, to provide access to and conserve water through people's participation. What will I be able to do? By the end of this project, you will be able to: first, measure and calculate water availability, usage, and wastage. Second, collect data on total water availability and trends in water consumption. Third, analyze and compare data related to water usage. Fourth, identify and implement practical ways to reduce water wastage. What will I need? To do this project, you will need the following: a notebook and pen, measuring jar to be replaced by an equivalent like a 1-liter bottle, basic plumbing tools, wrench, spanner, pipes, bucket, mug, consumables for plumbing, stopwatch or timer. Mobile app can be used. Survey form for asking questions can be written or printed. Calculator. Mobile calculator app can be used. Computer and connectivity for online research, data calculations, and analysis, and use of digital spreadsheets and programming languages. Page number 113. How do I keep myself and others safe? First, handling tools. Use all tools, especially plumbing tools, carefully. Follow all safety precautions as prescribed for the use of tools. Second, outdoor safety. Always take permission before entering someone's home or property for the survey. Be careful around slippery areas or water sources. Stay hydrated and avoid working in extreme heat. Third, internet safety. Ask your teachers for help while using the internet. Be careful not to upload or download anything. Do not share your or anyone's personal information anywhere. Use data only from reliable sources like government departments, websites, and national research institutes. What do I need to know before I start? To carry out a water audit, you need to know the water consumption in your community. For this, you need data. You will collect primary data related to water consumption in the community and secondary data related to the availability and supply of water. Box information, primary and secondary data. Data that is collected first-hand is called primary data. It can be collected by survey, experimentation, interviews, observations, any method that involves direct collection of data. For example, the data you collect during your science experiments or while surveying the community for projects. Secondary data is the data that is obtained from other reliable sources. For example, population data from government websites, water bodies in the region from government reports, area of a village from a government office, etc. Page number 114. Once collected, you will need to tabulate the data. To do this, you can use tools such as computer spreadsheets to enter the data. Before you start, you need to prepare for collecting water-related data. You need to decide about methods and units of water measurement. Activity 1. Water measurement methods. You have learned in science about units of measurement of liquids. Water is measured in milliliters, ml, for small quantities, but liters, L, are more suitable for household use, and cubic meters, m cube, for larger quantities like municipal supply or water storage. Figure 5.3. 1 cubic meter of water equals 1000 liters. Figure 5.3. Graduated cylinders and cups for measuring water. There are pictures given in this figure of different sizes of measuring cups. Operating manuals of machines such as washing machines and reverse osmosis RO water purifiers provide you specifications of the amount of water they use. The use of machines using water, example washing machines and RO machines, indicate the amount of water consumed during their functioning. However, the challenge is to estimate the amount consumed while bathing, washing utensils, and so on. Using tools like a graduated cylinder each time for recording observations is not convenient. Hence, we need to use common utensils, example, bottles, glass, etc., to measure water usage in daily life. Generally, the amount of water in liters is printed on plastic buckets or cans. Page number 115. If not, the amount of water stored in utensils in your home or school can be measured using any other utensil for which the storage capacity in liters is known. Example, a 1 liter bottle. This will help you collect data from people. For example, how many buckets of water they consume to wash clothes. Calculate the water flow rate measured in liter per minute for taps and showers. To measure the water flow from the tap, let it flow into a bucket for a minute. Measure the amount of water collected in the bucket. Now, you can measure the amount of water consumed by noting how long a person keeps the tap running when the tap is on while washing utensils. You can calculate the water consumed using the flow per minute you measured. Amount of water used is equal to water flow rate of the tap, liter per minute, multiplied by time tap is kept on. Fill in the blanks for utensils at your home in figure 5.4. You can substitute any object that is not used in your home. Figure 5.4. Using utensils to collect data on water usage. In this figure, there are 4 sections. First section has different utensils like a glass, an earthen pot, a bucket. The second section has capacity or water flow. Blank space is provided with each utensil for you to write how many liters can these utensils carry. There is blank space provided with each utensil for you to write down their capacity or water flow. The third part has utensils, namely water drum, flush tank, and a tap. In the fourth part, capacity or water flow is given. In this part, you have blank space provided for you to write down the capacity or water flow of each of these utensils. Applying this method, you can calculate the capacity and flow of any utensil or water taps or shower or water pipe in the house. Page number 116. Water storage capacity in the society. You can calculate the capacity of the big water tanks, figure 5.5, in the locality by using the dimensions marked on them, calculating the volume and then converting it into liters. You can also talk to the water supply officer of your area to find out the quantity of water supplied to the society. Figure 5.5. Water tanks store water and taps supply it to the community. There are two pictures given in this figure. The first picture is of an overhead water tank. The second picture is of a water tap. The second picture is of an outdoor community water tap. Reflect on your learnings. Question 1. What is the water storage capacity of the water tank in your locality? Blank space is provided for your answer. Question 2. How much water is supplied daily to your locality? You can get this information from the local municipal corporation, Gram Panchayat office, or water supply authority. Blank space is provided for your answer. Question 3. How many people use this water? You need to know the population of the locality. You can get this information from the local municipal corporation, Gram Panchayat office, or water supply authority. Blank space is provided for your answer. Page number 117. Box information. Sources of water. Water received from rains comes to us through natural as well as man-made water sources. Rivers, wells, borewell, tanks, etc. Figure 5.6. It gets stored in big and small dams. Water from dams or storage tanks comes to us through canals, pipelines, etc. Knowing where your water comes to you and how much population is dependent on this water is necessary for your audit. Figure 5.6. Mapping water sources in a locality. There is a picture given in this figure where there is a prototype of mapping of a locality with all the water resources that it has. Activity 2. Interview with an official of the water supply department. Usually, the water supply to our homes is managed through the Gram Panchayat office, municipal corporations, water supply department, ward office, and similar bodies. You can visit these offices to understand the water supply system of your locality. It is essential to prepare a list of questions before the visit. Some questions are given. Please add or remove questions if you wish. Question 1. What is the source of water for our locality? Blank space is provided for your answer. Question 2. How much water does each household receive per day? What is the amount of water allotted per day per person? Blank space is provided for your answer. Question 3. Do you face any challenge in supplying sufficient water to all? What are those challenges? Blank space is provided for your answer. Page number 118. Question 4. How does rainwater contribute to water availability in your area? What efforts have been made to store rainwater for later use? Blank space is provided for your answer. Question 5. Are there any seasonal changes in water availability in the locality? Blank space for your answer. Question 6. Any suggestions for water management by individuals? Blank space for your answer. Question 7. Create a simple neighborhood map showing water sources like wells, tanks, or water delivery points. Ask the official for help if needed. There is blank space provided for a simple drawing. Page number 119. By learning these basics, you will be better prepared to conduct the water audit and take actions. These activities will also help you understand the water situation around you more clearly. Activity 3. Estimating average consumption in a household. It may not be possible for you to collect data from each household in the locality. Therefore, you can select a few houses. You can plan to collect data from a minimum of 10 families. If you are working in a group of 5 students, this will collectively become data from 50 families. This will also help you understand water consumption in your home. It will be convenient to record the data in your notebook. After returning to school, prepare a table in a spreadsheet on the computer. You can apply formulae in the spreadsheet. This will help you analyze data and present it in different forms, like graphs and pie charts. If you do not have a computer, you can make tables to enter data in your notebook and use a calculator. Box information. Did you know? A. Washing machine consumes approximately 70 liters per cycle. You can check online from the website of the manufacturer. Figure 5.7. A. Washing machine. There is a picture in this figure of a washing machine. B. RO water filter wastes approximately 3 liters of water per every 1 liter of treated water. Figure 5.7. B. RO filter specifications indicate the amount of water used. There is a picture of an RO water purifier that is given here. Table 5.1 contains a sample of a form you can use to collect data from the field. You can change it to suit your purpose or use it as it is. Page number 120. Table 5.1. Form to collect data on water usage from a family. There's a table given where there are 2 columns and 14 rows. The first column across all rows have different questions. The second column across all rows is kept blank for you to write your own observation. Row 1, column 1, name of the family. Row 2, column 1, number of people in the family. Row 3, column 1, how much water is stored in the house in a day. Example, 1 tank of 1000 liter capacity, 1 earthen pot of 5 liter capacity, 1 copper vessel of 15 liter. Fourth row, first column. How much water does the family consume per day for washing clothes? Example, water used in a washing machine. Number of buckets used. Row 5, column 1. How much water does the family consume per day for washing utensils? Example, water flow of the tap and average time spent on washing utensils, buckets used. Sixth row, column 1. How much water does the family consume for drinking and cooking? Example, amount of water stored in bottles and average number of bottles used. Row 7th, column 1. How much water does the family consume for bathing? Example, buckets use the water flow of tap or shower and time used for bathing. Row 8th, column 1. Do they face any water shortage? How do they manage in case of water shortage? Row 9th, column 1. Do they have any machines or appliances? Do they have any machines or appliance that consume water? How much water is consumed by each of these appliances? Example, washing machine or RO filter. Note, not to be repeated if covered in questions related to washing clothes and drinking water. 10th row, column 1. Any other use of water? Example, for washing vehicles in the garden. Row 11th. Do they have any other source of water? Example, well or borewell or purchased water. Row 12th, column 1. What do they do with the water if the stored water is not consumed on the same day? Do they recycle it or throw it away? Row 13th, column 1. Do they receive a water bill? If yes, how much is it generally? Row 14th, column 1. Is there any other observation concerning water availability and usage? Page number 121. The family will give you estimates. You need to calculate the amount of water used in terms of the capacity of buckets, mugs, bottles, and so on. You will also need to calculate water flow from taps, showers, and water pipes in case of water usage for gardening for each home you visit. If a person uses water from an overhead tank, you need to talk to them and estimate water usage based on their lifestyle. For example, taking a bath twice on a daily basis or washing 2 buckets of clothes daily. Once you have collected the data, you must tabulate it in a spreadsheet or notebook. You can decide the categories for data based on water consumption for activities like washing clothes, RO water use, car washing, and so on, based on your observations, information gathered, and logical reasoning. The accuracy of your analysis will depend on the primary data. Hence, it is necessary to maintain the integrity of the data. It should be as accurate, reliable, and consistent as possible. You may have collected some data that is not in the form of numbers. This cannot be used for the calculations. Tables 5.2 and 5.3 show examples of using formulae in Excel to analyze the data. Table 5.2. Using formula in Excel to analyze data. There is a picture of an Excel sheet given here for your better understanding. It has the data of different households and their water consumption. It also helps to make you understand how to put formula in an Excel sheet. Page number 122. Table 5.3. Using formula in Excel to analyze data. There is a picture given in which the final values and calculations in this table, the final values and calculations are given of different households that were mentioned in the previous table. Can you find out the average consumption per person from your data? Box information. Hint: when you divide values in the G column from those in the C column, Excel will answer you automatically. To add the total, you can use formulae like is equal to sum in bracket A1 इसको क्या बोलूं बाय बोल दूं A1 by A5 कंफर्म अच्छा ये कोलन तो है इसको ये एक्सेल शीट का है ना क्योंकि कोलन ही बोलते हैं अच्छा ओके रिपीट To add the total, you can use formulae like is equal to sum in bracket A1 colon A5. In MS Excel, explore other formulae by searching online or asking your teacher. You can add, subtract, divide, and multiply using formulae to save time. However, a calculator is as effective. All the data is to be recorded in liters only. Question 1. Find out the average consumption per person from your data. You can use the formula in a spreadsheet. There is blank space provided for your answer. Question 2. Are there any families that are consuming more water than average? If yes, what is the reason? Blank space for your answer. Page number 123. Activity 4. Rainwater availability in your district or town or village or ward. Secondary data collection. When you obtain data from other sources, it is called secondary data. As mentioned earlier, you must use the information from a reliable source. A government website or report, or officials working in the municipal corporation or Gram Panchayat or water supply office. You must also refer the site or document. This activity will help you learn how to estimate the rainwater available in a geographical area using secondary data. Use Table 5.4 to record the findings of your survey. It contains an example. Table 5.4. Recording data to estimate rainwater availability. There is a table given with 5 rows and 4 columns. The heading of the first column is Examples. The heading of the second column is About your district or town or village or ward. Heading of the third column, Reference or source of information. Heading of the fourth column, What does the data tells us? There are different examples that are shared here, along with what does the data tell us about those examples. The second column across all rows have been kept blank for you to write your own responses. The third column across all rows, row 1, column 1, example. Population, district or town or village or ward. For example, Pune district, 94,29,408. Column 2 and 3 are blank in this row. Row 1, column 4. What does the data tell us? Number of people depend on water sources. Row 2, column 1. Example. Area of district or town. For example, Pune district, 15,643 square kilometers. Column 2 and 3 are kept blank in this row. Row 2, column 4. What does the data tell us? Area that will receive rainfall. Row 3, column 1. Example. Rainfall of the district in the year. For Pune district, rainfall in 2023, 446 millimeter, which is 0.446 meter. Column 2 and column 3 in this row are kept blank for your own response. Row 3, column 4. What does the data tell us? Rainwater availability. Row 4, column 1. Example. Total water availability. Area in meter square into rainfall in meter. 1 meter cube is equal to 1000 liter. 1 kilometer square is equal to 10 lakh meter square. Total water availability in Pune district, 15,643 into 10 to the power 6 into 0.446 is equal to 6,977 into 10 to the power 6 meter cube is equal to 6,977 into 10 to the power 6 into 1000 liter. Fourth row, second column, calculation. Fourth row, third column has been kept blank for you to write your own response. Fourth row, fourth column. What does the data tell us? Water received in the district through rainfall. Fifth row, column 1. Generally, 70% of total rainwater is required for agriculture, including farm animals, 20% of industry, and 10% for domestic consumption. On the basis of this, Calculate rainwater available for consumption in your district. For example, rainwater available for domestic use in Pune district is equal to 6,977 into 10 to the power 6 into 1000 into 0.1 is equal to 697.7 into 10 to the power 6 liter into 1000. Per capita rainwater availability is equal to 697.7 into 10 to the power 6 into 1000 divided by 94,29,408 is equal to 73,991 liters. Per day rainwater availability per person is equal to 202 liters per day. Fifth row, column 2, calculation. Fifth row, column 3 is kept blank for your own response. Fifth row, column 4, what does the data tell us? Rainwater available for different purposes. The above information will help you understand rainwater availability, usage and scarcity in your geography. Calculating water availability based on a district's geography and rainfall may not give you an accurate picture. All rainwater flows into rivers. The entire population from the origin of the river up to the point where the river meets the sea depends on river water. Some of these areas have high rainfall and some have less rainfall. However, the water in the river basin belongs to the entire population. Activity 5. Compare and analyze the data. The data speaks for itself. What did your data say? Table 5.5 will help you compare the average consumption versus the prescribed consumption. You may recall that you estimated average consumption in Activity 3, page number 125. Box information. Suppose you want to refer to secondary data. The person who is listening to you or reading a report you have written must know where the data is from so that they can refer to it. They would also like to be assured that the data is reliable, since data keeps on changing. Example, population numbers change. Climatic parameters change. You must mention the year the data was reported. In which case, for example, you will say or write as follows. The Government of India, through Jal Jeevan Mission, is trying to provide 55 litre of tap water per day for rural populations. This secondary data has been obtained from a release of the Press Information Bureau of India dated 14th August 2024, which is available on the website of Press Information Bureau of India. If you are giving information from a book or report, then you must mention the name of the book or title of the report, and who has published it, and in which year. This information is available in the first few pages of the book or report. Now, try to obtain data from similar reliable sources. You can search the library, newspaper reports, magazines, and publications to get the data. Alternatively, use online search with following keywords. First, rainfall plus year plus name of district. Second, population plus name of the district plus census. Third, water availability per person plus name of the district. Fourth, Ministry of Statistics plus Government of India plus water. Fifth, Niti Aayog plus water report. Table 5.5. Record of average consumption versus prescribed consumption. There is a small table given here with 1 row and 3 columns. The heading of the first column, average consumption per person per day, primary data. The heading of the second column, water available per person per day, as per secondary data, calculations done by you. The heading of the third column, prescribed usage per person by Jal Jeevan Mission. First row, column 1, is kept blank for you to write your own response. First row, column 2, is kept blank for you to write your own response. First row, column 3, 55 litre per day for rural areas and 135 litres per day for urban areas. Small note: this is the prescribed usage in 2025. You can look up the prescribed consumption on the Ministry of Jal Shakti website. Page number 126. Water availability can be increased in the following ways. First, planting trees. Second, reducing pollution to increase rainfall. Third, reducing wastage of water. Fourth, recycling water. And fifth, water conservation methods like rainwater harvesting. Activity 6. Identify wastage points and amount of wastewater. This activity involves inspecting areas where water is wasted, such as leaking taps or overflowing tanks. You can focus on areas that need immediate attention by identifying wastage points. Often leakages need a little attention to fix them. Inspect common areas where water gets wasted, such as taps in your school or homes, pipelines, or overhead tanks. Look for signs like dripping taps, figure 5.8, wet patches under pipes, or overflowing tanks. Record your findings in a notebook. Note down the location and type of problem. You can record the wastage of water by using a bucket and a stopwatch. 1. Start the stopwatch when water starts to waste. 2. Stop it when the wastage ends. 3. Note the time duration. 4. Repeat the process. You can calculate the volume also. Now, share your observations. You can take simple steps to reduce wastage. Figure 5.9. Figure 5.8. Recording wastage of water due to a dripping tap. There are 3 pictures given here of a dripping tap. First has a dripping tap. Second has a bucket under a dripping tap with a stopwatch, and the third has a bucket full of water and a stopwatch which gives the time taken to fill the bucket with dripping water. Page number 127. Figure 5.9. Steps to fix a leaking tap. There are different steps given here on how to fix a leaking tap at home. It also has different pictures for your better understanding with every step. 1. Fixing a leaking tap. Start with easy solutions like tightening the tap and changing the washer. You can invite a local plumber to learn about the tap mechanism and tools like plumber tape and wrench. You will have to turn the water mains off before you start work. Using a spanner, take off the tap's cover to remove the handle. You will probably find this under the hot or cold sign. There is a picture given where a person is taking off the tap's cover to remove the handle. Undo the screw and remove the handle. If the tap has a metal cover, unscrew it by hand or use a wrench or tap spanner. There's a picture given where a person is unscrewing and removing the handle manually. Unscrew the tap bonnet and completely remove the headgear. You should see a large body washer, O-ring and jumper valve. The jumper valve should fall out. There are two pictures given here in which a person firstly unscrew the tap bonnet and then in the second picture is removing the headgear completely. Replace the body washer, the O-ring and the jumper valve with new parts. Apply a tap lubricant to the spindle and valve for better sealing and smoother tap operation. There are two pictures given here. The first one has body washer for the tap, the O-ring and the jumper valve with some new parts. In the second picture, a person is applying a tap lubricant to the spindle and valve for a better sealing. Refit the bonnet and spindle. Be careful not to over-tighten the nuts. There is a picture given here where a person is refitting the bonnet and spindle. Put the tap back together. Turn it off and turn the water back on. Now, check the tap to make sure it is no longer leaking. Now, you can step back and admire the proper job done, knowing you are not wasting a drop. There is a picture given here where a person is putting back the tap together. Page number 128. 5. Reduce the use of water. Most of us have a habit of opening the tap at full throttle. You can restrict the water flow per minute by using aerators or flow caps available in the market. You can also simply open the tap partially when using water. Figure 5.10. Figure 5.10. Comparison of water flow with and without flow cap and aerator. In this figure, there are three pictures of a water tap. The first water tap is open full tap throttle. In the first picture, there is a tap which is open full throttle. In the second picture, there is a tap with flow cap. In the third picture, there is a tap with aerator. Groundwater recharge. You have learnt about groundwater in science. As you know, well water and borewell water are essential water sources. One advantage of storing water underground is that evaporation losses are minimal. Unfortunately, due to uncontrolled groundwater extraction, water levels are depleting alarmingly. While many efforts are being made through various water conservation programs, there are efforts that communities can make to help rainwater percolate into the ground. You can participate as volunteers in programs around you. The basic principles of water conservation and an example of how they can be applied are: first, to hold the water in the field. This can be done by making contour bunds on the ground. Figure 5.11. Contours are lines connecting points at equal elevation. Bunds made up of earth to prevent water from running off the slope. On contour lines, hold the water at the same level. This also helps in reducing soil erosion. Page number 129. Figure 5.11. Contour lines hold the water at the same level. There are two pictures given in this figure. These pictures help us understand how the contour lines hold the water at the same level. Second, to reduce the speed of runoff water from the field, a small check dam can be built on the water stream. Figure 5.12. Check dam on a water stream used for irrigating fields. There's a picture given in this figure where the villagers have made a check dam on a water stream. Third, to let the water percolate inside the ground. This can be done by making a percolation tank, dam, borewell recharge, etc. Figure 5.13. Figure 5.13. Percolation tank for groundwater recharge. There is a picture given of a rural area where the villagers have made a percolation tank to restore groundwater. Page number 130. Activity 7. Reusing water. When we use water for cleaning, bathing, and other activities, it gets contaminated with dirt, oil particles, and other impurities. It is possible to reuse the water by removing impurities. When water flows through the river, weeds like hyacinth absorb minerals that are mixed into water. Oxygen mixed in water decomposes organic matter, and sunlight kills harmful bacteria. Through these natural processes, river water becomes clean when it flows. Wastewater from domestic use, like wastewater from sinks, baths, washing machines, and kitchens, is called grey water. Instead of letting this water go to waste, it can be used for some purposes, such as irrigation, cleaning, or even groundwater recharge. As a part of our efforts to reuse water, you can try any of the following grey water recycling systems. First, wastewater from washing vegetables or cooking is used to water plants. Runoff water from a hand pump or a washing sink to ensure the water is not too soapy can be used to water the kitchen garden. Figure 5.14. Figure 5.14. Using leftover water for watering plants. There is a picture given in this figure where a young girl is watering the kitchen garden using the leftover water from her kitchen. Box information. Grey water can be used for flushing toilets. You can search online with the following keywords. First, DIY plus grey water system plus Indian toilet. Second, DIY plus grey water system plus toilet flush. Page number 131. Second, installing a reed bed grey water system at your school or visiting a grey water recycling system. You can make a reed bed system for wastewater from your school. Figure 5.15 and 5.16. This follows a natural filtration mechanism. Grey water is collected in a tank to settle the suspended particles. This is called the sedimentation tank. Water from the sedimentation tank passes through the roots of plants like Canna indica, Colocasia, and many other local water-loving plants, which absorb the organic pollutants and heavy metals. Figure 5.15. Reed bed setup. There's a picture of a reed bed setup in a person's courtyard that is given here. Figure 5.16. Reed bed system for reusing wastewater. There is a picture given in this figure on how reed bed systems can be used for reusing wastewater. The first step in this picture is grey water inflow. Then the water goes to the sedimentation tank. Then it goes to the filter tank. From there, it goes to the plants like Canna indica. After this step, the water is treated. Box information. You can search on the internet using the keywords. First, DIY plus grey water system. Second, grey water system treatment plus design. Reflect on your learnings. On the basis of the water-saving activities, reducing consumption or reusing water carried out in school, answer the following questions. Page number 132. Question 1. What initiative have you taken to reduce water usage? Blank space is provided for your answer. Question 2. Write down details of the activity you carried out. Blank space is provided for your answer. Question 3. Amount of water saved per day. Estimated. Blank space for your answer. Activity 8. Estimate future water requirement. You have used primary data to estimate average consumption of water. You have used secondary data to learn about water availability in your locality. You are now ready to estimate future water requirements in different scenarios. Respond to the questions in Table 5.6 and 5.7. Question 1. What is the increase in the demand for water if a housing society of 100 homes is constructed near your village? You can estimate 4 people per family. Table 5.6. Record of data on increased demand in Scenario 1. There is a table given here with 6 columns and 1 blank row for you to write your own observation and response. The heading of the first column, serial number. The heading of the second column, number of families. The heading of the third column, total number of members in the family. The heading of the fourth column, average consumption per family. The heading of the fifth column, total increase in consumption. The heading of the sixth column, increase in overall consumption in your locality. Page number 133. Question 2. What will be their water requirement if a college hostel has 1,000 students? Table 5.7. Record of data on increased demand in Scenario 2. There are 5 columns and 1 row which is kept blank for you to write your own observation and response. The heading of the first column, serial number. The heading of the second column, number of additional consumers of water. The heading of the third column, average consumption per person. The heading of the fourth column, total increase in consumption. The heading of the fifth column, increase in overall consumption in your locality. What did I learn from others? Identify what you learned during field trips, online and offline interactions with experts, family and friends, community members, and other sources. First, name any one thing that you found surprising where use of water is concerned. Second, write any 3 things you learned that will help you save water in your life. What did I do and how long did it take? It is important to understand how much time is required for an activity to be completed. Calculate the approximate number of hours you spent on each activity. Mark them on the timeline below. If you did more than the activities suggested in the book, please add the number and time taken. Page number 134. What else can I do? After finishing your project, here's what you can do next. First, you can use computer programming to write a program to help users estimate water requirements and consumption patterns. Second, you can write a letter to government officials informing them of your findings and suggestions, like promoting greywater for the garden, fixing leaking taps, or recharging the borewell near the hand pump or rainwater harvesting. Third, as you did a water audit, you can also carry out a grocery, food waste in the kitchen, or electricity audit. Fourth, study about a solar water tank that stores hot water heated by solar thermal collectors. Also, study how it is being used for residential and commercial purposes. Think and answer. Question 1. Did you enjoy doing this project? Question 2. What did you like and what would you do differently next time? Question 3. Using a map, trace the path of the river closest to your locality. Look at the adjoining districts the river path passes through in your state. Which areas are drought prone or have surplus rain? Are there any dams on the river? How do you think the river impacts people's lives? Question 4. Examples of jobs related to the work you did are environmental scientists. Examples of jobs related to the work you did are environmental scientist, environmental engineer, industry professional, social worker, auditor, etc. What other jobs are related to the project? Look around, speak to people, and write your answer. Project 5 ends here.
Kaushal Bodh. You were just listening to this audiobook, Textbook of Vocational Education for Grade 8. Narration Himani Joshi. Sound recordist Muhammad Faizan Khan. Assistance in production Vineet Kumar Sharma. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.